welcome to today's tutorial. In the course of today's tutorial, we'll be talking about basic strength of material. Now, in this course, we'll be talking about so many things that has to do with what? That has to do with what? Basic strength to material. The first thing we'll talk about is what we call stress and strain. Now, what is stress? Stress is the force per unit area. Stress is the force per unit area that a material experiences when subjected to an external force. That a material experiences when subjected to an external force. Now, what are those external forces? The external force might be of compression, tension, or what? Torsion. Now, these are external forces. So these external forces might be applied to an object for that object to move through a certain distance. So when an external force is applied to an object is what we know as what? Stress. And we said what? Stress is what? Force per unit area. Stress is represented by a symbol called sigma. So sigma is a symbol for stress. And this is the symbol. And we said what? Stress is a what? Is a product of what? Force per unit area. Now, what is the unit for stress? The unit for stress is what? Newton per meter square. Because force is measured in what? Newton, and area is measured in what? Meter square. Let's take an instance. What if we apply a pressure on an object? What can we say? Are we still applying force to that object? Yes. Why? Because pressure is a what? Is a type of force. So we can say what? Stress is equal to pressure over area. And we have the same unit as Newton per meter square. Because pressure is a what? Is a type of force. Let's take down strain. What is strain? Strain is the deformation produced by stress. Strain is the deformation produced by stress. So let's say what? They say what? Strain is what? It is the deformation caused by stress. Meaning, if stress is not occurring, then what? Strain cannot what? Occur. Now, what is deformation? Deformation here simply means what? Change in what? Extension over what? Change in what? Size. Just like having what? We can say what? Strain is now what? Deformation. And we know deformation is what? Extension over length. Now, strain is represented by a symbol called epsilon. So strain is represented by a symbol called epsilon. Now, what is that symbol? This is what? Epsilon. So we can say what? Epsilon is equal to what? Extension over length. Now, what is the unit for strain? Strain, which is what? Epsilon is equal to what? Meter over meter. Because extension is measured in meter and length is measured in meter. So if the meter cancels this meter, epsilon has no unit. So what? Strain has no unit. So if you are asked what is the unit for stress, the unit of stress is what? Newton per meter square. And what is the unit for strain? The unit has no unit. Take this down. Relationship between stress and strain. Take this down. The relationship between stress and strain is what we call Young modulus. So Young modulus E is equal to stress over strain. So if you are asked what is the relationship between stress and strain, the answer is what? Young modulus. And Young modulus is represented by a symbol capital E. We know stress, we know that what? E is equal to what? Stress over epsilon. And we know that what? Young modulus is equal to what? What is our stress? Force over area. Force over area. And what is epsilon? Epsilon is what? Extension over length. So if we rearrange this, we have that what? E, which is Young modulus, is equal to force over area multiplied by what? Length over extension. So if you are asked, what is the formula for calculating what? Young modulus, simply say what? Force multiplied by what? Length per what? Area and what? Extension. What is the unit? We know that this is what? The unit is what? This is the Newton, this is a meter over meter square, and this is in what? Meter. So this is cancelling this. So the unit for Young modulus is simply what? Newton per meter square. So Young modulus have the same unit with your stress. Now take this down. Types of stress. Basically, we have different types of stress, but what we'll be talking about today is what? Two types of stress, which are the tensile stress and the compressible stress. So the first one, we have the tensile stress, and two, we have the compressible stress. Now, the tensile stress is a stress due to pull. Tensile stress is a stress due to pull. So if you have a material like this, and we are pulling this material, so if you see a diagram like this, and we are asked what is the stress occurring in this diagram, we simply say what? This is the what? A tensile stress. Because it is stress due to what? Pull. We have the second one called the compressible stress. The second one is called the compressible stress. But before we go into the compressible stress, the tensile stress can be called axial stress. So another name for your tensile stress, it can also be called tensile stress or what? Axial stress. Because it's a stress occurring in an axis. Now the second one is called what? The compressible stress. Take this down. The compressible stress is the stress due to push. Now, if you have an object of this manner, and this object is pushed towards this direction, so the stress due to pushing this object like this and like this is called the what? Compressible stress. Now your compressible stress can also be called hydrostatic stress. So if you are not seeing compressible stress, you'll be seeing what? Hydrostatic stress. Don't be confused. Types of friction. Types of section. I would say you have basically two types of section. The first one is what? Sharp. And the second one is what? Sharp. Anyone. And we said for us to know Halloween, he will tell us in the question. Abi? Yes. And I told you Halloween is when you have something like this. Yes. When you have a small circle in a bigger circle. And we said to calculate for the area, we first get the big diameter. And I said to calculate for the big diameter, which is for the big circle, we said what? D is equal to what? Small d plus what? T plus T. These two. Now, if you simplify this, you have what? D is equal to D plus 2T. That's what we said. And we said to get the area for hollow, the area for hollow is what? We said A is equal to pi over 4 bracket big diameter square minus small diameter square. Abi? We talked about shafts. And we said shaft is just when we are having a plane shape. Let's say plane shape, just like just a circle. And I told you to calculate the circle, we use the formula A is equal to what? Pi arrow square. But in the case where we are given a diameter, what do we do? The area for this shape is what? A is equal to pi over 4 d square. Abi? Yeah. Take this down. A hollow cast iron cylinder, 4 meter long, Abi? And 300 outer diameter, with thickness 50 millimeter. With thickness 50 millimeter. And is subjected to a center load when standing straight. The stress produced is 75000 kilonewton per meter square. The stress produced is 75,000 kilonewton per meter square. Assume E for cast iron to be 1.5. Capital E. Yes. And what is our E? Young modules. 1.5 times 10 raised to the power of 8 kilonewton per meter square. A. Calculate the magnitude of the load. The second one is longitudinal strain produced. Then the C says what? Calculate for the total decrease in length. What are we going to do? We are going to bring out our parameters. Abi? Yes. The first thing is what? Solution. Let's bring out our data. What's the first thing given? They gave us the length, which is what? 4 meter long. What else? 200 millimeter outer diameter. So they gave us big D to be what? 300 millimeter. So to convert millimeter to meter with what? Divide by 1000. And this is equal to what? 0.3 meter. What's the next thing? Thickness 50 meter. They give us thickness 50 millimeter to be what? 50 millimeter. Now convert your millimeter to meter, you have what? 0.055 meter. What's the next thing? Stress produced. Stress. And we said stress is represented by what? Sigma. And they said sigma is equal to what? 75,000 kilonewton per meter square. What do? We convert this to Newton per meter square. So converting that, what is this? It will be 75000 multiplied by 10 raised to the power of 3 Newton per meter square. They gave us young module, which is E. And they said E is equal to what? 1.5 times 10 raised to the power of what? 8 what? So converting the kilo to Newton per meter square, we what? Multiply by what? 10 raised to the power of 3 Newton per meter square. What's the next thing?
That's all.
That's all. They said the first thing is to calculate for what?
Magnitude.
So we have to calculate for A, magnitude. What's the second thing? To calculate for what?
Longitudinal stress.
Longitudinal strain. Strain. And strain is represented by what? Epsilon. What's the next thing?
Total decrease in length.
Total decrease in length, which is what? Extension. So we can represent it with E to be extension. So these are what it told us to do. Calculate for. Now, how do we calculate for P? We use stress equal to force over area. Are we given the area? So what do? We have to get the area. And in our question, they said what? Hollow. So we are using what? The area for hollow. Now what is the formula for the area for hollow?
5 over 4.
So A is equal to 5 over 4 brackets what?
Capital D squared minus small d squared.
So this is the formula. But you know that we don't have small d. Are we given small d?
No.
So can we use that formula?
No.
We cannot use that formula, Abi. So what are we going to find? So we can use this formula, small d, Abi. But recall that big D is equal to what? D plus what? 2t. Are we giving t?
Yes.
Are we giving big D?
Yes.
So we can apply this formula. So what are we making subject of formula?
Small d.
Small d. So small d is equal to what? We are taking this to this other side. So it will be what? D minus what? 2t. And we know our d, Abi. What's our d? 0.3 minus 2 bracket. What's our t? 0.05. So d is equal to what? 0.2 meter. So can we use this formula to calculate for our area?
Yes.
So using the formula, A is equal to 5 over 4 bracket. What's our big D?
0.
Our big D is what? 0.3 square minus what's our small d? 0.2 square. So what do you think the area will be? 3.93 multiplied by 10 raised to the power of what? Minus 2. And what's our unit? Meter square. So what can we do to get P? But we are given stress. But we know that stress is equal to what? P over A. We are to look for P, but we know stress, which is sigma. What is sigma?
75,000.
So we have 75000 multiplied by 10 raised to the power of what? 3. And this is equal to P over what's our area? 3.93 times 10 raised to the power of minus 2. So what is our P? Our P is equal to 75000 multiplied by 10 raised to the power of what? 3 multiplied by what? 3.93 times 10 raised to the power of what? -2. So our P is what?
294
294
7500.
7500. And what is the unit? Unit. But we know that young modulus is equal to what? Stress over strain. Now, what is young modulus? 1.5 times 10 raised to the power of what? 11.
Yes.
And this is equal to, what's our stress?
75,000
75000 times 10 raised to the power of what? 3 over strain is what? Epsilon. Abi? Now, epsilon is equal to what?
7500.
So 75000 multiplied by 10 raised to the power of what? 3 divided by 1.5 multiplied by 10 raised to the power of 11. So what is our epsilon? I think that should be 2 point something.
2 times 10 raised to the power of -8.
So we have 2 times 10 raised to the power of
-8.
-8. And what is the unit for extension? Meter. So that is it. We said there are basically 2 types of stress. And the first one we said we have what? Tensile stress. And we have B to be what? Compressible stress. And we said our tensile stress is also what? Is also called axial stress. So if you are hearing axial in the question, then they are asking us to get what? Our tensile stress. The second one is what? Compressible stress. And we said the compressible stress is also called what? Hydrostatic stress. And we said tensile stress is stress due to what? Pull. So if you have a body or if you have a material and we are moving this material this way, we are moving this material this way. This is what? This is a tensile stress. And we said what? Compressible stress is when we are what? Pushing the material. Abi? So stress due to push is what we call what? The compressible stress. And we said a positive stress is also called what? The tensile stress. Whilst the negative stress is also known as what? Compressible stress. Now let's sit down. A brass bar having a cross-sectional area of 1000 millimeters square is subjected to an axial force as shown in the figure below. Find the total change in length of the bar. Take E to be 105 giganewton per meter square. So when we say giga, what do we mean?
Giga is
So we can say that E, which is young modulus, is equal to what? 105 multiplied by 10 raised to the power of what? 9 Newton per meter square. We have to find the total extension. That's extension for bar 1, extension for bar 2, extension for what? Bar 3. Now the total extension will now be what? ET is equal to E1 plus E2 plus what? E3. But what are we going to do first? We are going to resolve this first. We are going to resolve this. Now let's call this what? Bar 1. Let's call this what? Bar 2. And let's call this bar 3. Now in bar 1, this is bar So bar 1 is what? LM, abi? And what is the force you are seeing there?
50.
Bar 2 is what?
M.
And what is the force?
80.
Bar 3 is what?
MP.
And what is the force? 20. Note, 50 is the force for what? LM, because it's the one going out. Abi? Now, MN, we have a force in this direction. NP, we have what? A force in this direction. Then this 10 kilonewton is the force coming in. That is, this was the force applied to this material. So we are not considering it first. You understand?
Yes.
Now, looking at LM, is it a tensile stress or a compressive stress?
Tensor.
It's a tensile stress because what? It is going out. And we said what? A tensile stress is a what? A positive stress. Abi? So can we say that what? For bar 1, for bar 1, we have what? P is equal to what? 50 kilonewton. Abi? So let's draw this. This is for bar 1. We have a force in this direction, abi? Which is what? 50 kilonewton. Another one in this direction. You know why it's pointing this direction? Because you are pulling. Abi? So if you are pulling like this, you should be pulling like this. Abi? So this is what? 50 kilonewton. So what is our total P for E? For bar 1. So we know that P1 is equal to what? 50 times 10 raised to the power of what? 3 Newton. Are we done? We are done. For bar 1. I mean, the next thing is bar 2. Bar 2 will be what? We said bar 2 is, we are having what? M and N. And N is what? Mn is what? 80. Abi? And what are we seeing? Is it a compressible stress or a compressible force? Now, and we said what? A compressible force is a what?
Negative.
A negative force.
Yeah.
Now, what is the force we met before meeting this other one? 50. And 50 was what? A positive. So to get that one, we do what? This subtracted by what? This. P will be equal to, what is this one? Plus 50 minus 80. Why is it minus? Because it's a compressible force. So this will be what? P will be what? Minus 30 kilonewton. So we've gotten for the force for bar 2. Let's represent this. So what is our compressible force? It will be what? This man. And we have another one here, have we? And this is what? 30 AN. This is what? 30 A. So our P2 will be what? Minus 30 times what? 10 raised to the power of what? 3 Newton. So we've gotten the force for bar 1. We've gotten the force for bar 2. Now let's get the force for bar 3. And we said for bar 3 we have what? N and P. And what is the force you are considering there? 20. And 20 is a what? A positive. Now for bar 3. For bar 3, we know that what? Our P, what's our P for bar 2? Minus 30. And what force are we seeing here? Tensile force. And it's a what? Positive force. So to get P3 is equal to P3 what? P2 plus what? Plus plus 20. So we know P2 to be what?
20 minus 30.
So we know P2 is what? Minus 30 plus 20. Now, what is minus 30 plus 20?
Minus 30.
So minus 30 plus 20 is what? Minus 10 means minus 10. And minus 10 is what? When we see minus, it's a compressible force. Now, what is the force coming in?
10.
And so it's compressible. Now, if you do this and you are getting 30, and 30 is not here, you are wrong.
So the first one.
This one, we have it coming in, abi? Now we are considering it from this direction, abi? So we have what? Minus 10. Abi? What's the next thing we are seeing? If this is coming in, this is coming in too. So this is what? A compressible force, because we are considering it like this. So you are trying to push, you are still pushing this thing. So if you push it, continue pushing it is what? Minus what? 20. Now if you do that, you have what? Minus 30. So minus 30 will be the one standing here.
Okay.
Now what is the next one we are considering? The one opposing it. And the one opposing it is a what? A positive sign. So if we do that, we have minus 30 plus what?
80.
80.
This is giving you what? Stay by yourself.
So minus 30 plus 8 is what?
40.
Yes.
So we've gotten what? P3 to be what? P3 is equal to what? Minus 10 times 10 raised to the power
No
of what?
diagram.
3
No diagram.
like this.
Over 2x equals
So 10 kilo Newton, kilo Newton. So this is 1 and 0. What's the next thing? The next thing is to get your extension for each of the bar. So to calculate for the extension for bar 1, we know that what? E is equal to what?
F
P1 L1 over what?
over
A
E.
BP.
X young modulus. I mean,
E.
now if you do that, we know that what? P is equal to what? P1 is what?
50 times 10 raised to the power
50 times 10 raised to the power of what? 3. Multiplied by, what's the length? 0.6. 0.6 divided by, what is our area?
Area is 1,000 millimeters.
1000 millimeters. So 1000 millimeters will be written
One
as
square.
100 divided by 100 multiplied by 100 times, what is our young modulus? It will be 105 multiplied by 10 raised to the power of 9. So what is our EY? 2.85 times 10 raised to the power of minus 5 meter. So to get bar 2 will be what? E equal to P2L2 divided by what? A E. And we know what's our P2?
Minus 30.
Our P2 is what? Minus 30 times 10 raised to the power of what? 3. Multiplied by, what's our L2?
1.0.
1.0 divided by, what's our area? 1000 divided by 1000 multiplied by 1000 multiplied by what? 105 times 10 raised to the power of 9. So what is our E2? Minus what?
2.85
85
times 10 raised to
times 10 raised to the power of what?
minus 4.
Minus 4 meters.
Square.
The next thing is to get our what? Extension for the third bar. That's E3. E3 is equal to what? P3 multiplied by L3 over AE. But we know P3 to be what?
Minus 10.
Minus 10.
Minus 10 times 10 raised to the power of what? 3 multiplied by
1.2
1.2
Over
divided by, these are 1.2 divided by 1000 over 1000 multiplied by 1000 and multiplied by what?
E.
What's our E?
1.
105 times 10 raised to the power of what? 9. So what is our E3? Minus 1.14 times 10 raised to the power of what?
minus
Minus 4. In what? Meter. The next thing is to calculate for the total extension. Because that's the question. To calculate for the total extension, ET is equal to E1 plus E2 plus what? E3. Now what is our E1?
2.85.
2.85 times what?
10 minus 5.
10 raised to the power of minus 5. Minus, because your minus is knocking out this positive sign. You're left with what? Minus. Minus times plus. Minus. So we have E2 to be what? Minus what? 2.85 times 10 raised to the power of what? Minus 4. The next thing is what? E3. And E3 is what? Minus 1.14 times 10 raised to the power of what? Minus 4. The total extension ET will be equal to what? Minus
705
3.705 times 10 raised to the power of what?
minus 4.
Minus 4. That is our E total. So we've calculated for the total extension for the material given. Now what can we say? The system undergoes what? A compressible stress. A compressible stress. Because we are seeing what? A negative sign. And even it was a positive sign, it will be what? The system undergoes a tensile stress. So we can say what? The system undergoes a compressible stress.
look like